Okay, 1.2, measuring and constructing segments. Now this one has a lot to do with a compass and a ruler that we're going to have to do in class. In the YouTube playlist, I have another video that someone else made that I think kind of shows some of this stuff. Um, but in this one, I'm going to go over some of the problems, but there is going to be some compass usage that I'm not really going to be able to show you how to do. So you'll have to talk with me in class or watch that other video or find another YouTube video that explains it. All right. So starting off, we have another definition, an axiom or a postulate, right? Those right now, those are just going to be synonyms. They mean the same thing. They mean a rule that is accepted without proof, okay? It's a lot of those math things that you think of, some of the really easy things that you just kind of know. You know that it's true. You don't really have to be told that it's true. You just know that it's true. So let's look at 1.1, the ruler postulate. The points on a plane can be matched one-to-one with the real numbers, right? And the real numbers, that means like a ruler numbers, right? Counting numbers. The real number that corresponds to a point is the coordinate of that point, right? And I'm going to draw a picture down on the ruler, but I'm going to read the word distance as well first. Distance, the distance between points A and B, written as AB, is the absolute value of the difference of the coordinates. Right? Remember, absolute value is the little absolute value bars like that. We'll talk about that in just a minute. So we have a segment AB, and I'm going to draw that in just a second. Segment AB, that's the segment. That's talking about the actual, like, what you draw. Now, if you're talking about how long is AB, then you're going to write it as AB with nothing above it, right? That's talking about how long is segment AB, right? Segment AB, its length, it will either be the absolute value of the coordinates of A minus B or B minus A. Right? And I want to show you how we're able to get to that. So on your paper, just draw a little ruler. We only need the actual integers here, so draw the 0, 1, 2, 3, 4, 5. And I'm going to put a point on the 1, and I'm going to put a point on the 5. Right? This will be A, this will be B. Okay. Pretty easily right here, we can see that A is at 1, right? And B is at 5. Hopefully we can see pretty quickly that this piece actually is 4 units long, right? Now I want to talk about this piece here with the absolute value, because sometimes that can be kind of confusing. The way that that comes into play is we can say that this is either the absolute value of 1 minus 5, which is the absolute value of negative 4, which is just plain old 4, right? And what I did there is I took the 1 minus 5, or you can do it the other way around. And normally, if we're doing it in our heads or whatnot, we're probably going to do it the other way around. We'll say this is the same thing as saying the absolute value of 5 minus 1, which is the absolute value of 4, which is plain old 4. Okay? So really, distance, it's kind of something that we already know, but we're saying it in very specific terms here, okay? One of the points that I want to get across here is that we don't have to put our ruler at 0, right? We can put it at 1. We can put it at anything as long as we remember to subtract that off, okay? Now, number 1 here. This will be something that I show us in class, and it's going to be really hard to do digitally here. But what we're going to be doing in class is we'll draw a segment. It'll just be some kind of little segment like this. And we're going to copy its length using a ruler and a compass. Now, hopefully we all know what a ruler is, right? And a compass is the thing that we use to draw a circle, right? Normally there's a pointy end and then there's a pencil on the other end. And you can kind of swoop and make a circle, right? Now, the way that we'll do this, I'll kind of explain it, but you really need to watch the other video that I have. It's going to be the video right after this one in the playlist. To copy its length, we will first draw another line, just a long one, longer than our original. Okay, and we have one nice point on it. And then what we'll do is we'll take our compass, the thing that you would draw to a circle, and you're going to open it at one end and have it go to the other end of our original, right? And then you're going to leave it like that, and then you'll do the same thing on here. You'll make a little swoopy cut, and then there we've copied it, okay? I'll go over this in class using the compass, but if you're trying to watch the video, watch this video right after it. Let me see what the actual, it says, the title of it is How to Copy a Line Segment - Geometry, and it's one that I found from someone else, okay? So I know that's not really the best explanation for number one, but I'm going to go over that in class, and there's another video of it for you. Something that we really want to nail down is that lengths are equal. Segments are congruent. So if I have two segments, we'll say that they're both 5 units long. Here's A, B, C, and D. We would say that segment AB is congruent, so we have the equal sign with a little swoopy above it. That means congruent to CD, right? They're equal. They have the same length. We could also say that plain old AB equals CD, right? This is the segment, and this is the length, right? If you don't have the line above it, you're talking about the length of it, right? If you have the line above it, you're actually talking about that physical piece of it. All right, moving on to number 2 here. Let me get us some more space. We're going to plot these points in a coordinate plane, and then we're going to determine if segment PQ and segment RS are congruent. So let's draw a little coordinate plane. P is at -4, 3. So I'm going to go 1, 2, 3, 4, and then up 3, 1, 2, 3. Here is point P. Q is at 3, 3, 1, 2, 3, 1, 2, 3. Here's point Q. R is at -1, +4, 1, 2, 3. Well, I guess 4 is going to be up here. Let me see if I can. There we are. And S is at -1, -2 down here. Okay. It wants us to look at segment PQ, that's this here, and segment RS, right there. Okay. Now these are really nice because they're P and Q are on the same line this way, so we can just count over. We go 1, 2, 3, 4, 5, 6, 7. It's 7 units long, so I'm going to say PQ, the length is 7, right? Now looking at R and S, I can count. I can go 1, 2, 3, 4, 5, 6, 7. So RS is 7, right? What I'm saying here, what I wrote there in black, is that the lengths of them are both 7. Both of them are the same length, so I can say that they are congruent. So now I can say, well, PQ, the segment PQ, is congruent, the fancy equal sign, to segment RS. All right? And that would be my final answer, right? Because we were supposed to determine if they are congruent. So I'm writing that they're congruent. You could write the word yes if you want to. There's going to be some problems like this on the homework. All right. Next up, a definition. We have the word between, and it's going to mean exactly what you think. When 3 points are collinear, right, meaning they're on the same line, we can say one point is between the other two. So here on the left, we have a line, right? We have A, B, and C. They are collinear. They all are on that line. And we say that point B is between point A and C. And hopefully that's pretty easy for us to see. Now in the second picture, E is not collinear, right? It's not on the line. So we cannot say that it's between, even though you could kind of say, oh, well, it's kind of between, right? It's kind of between. We're not going to say that. It is not between, okay? It has to be on the line for it to be considered between. All right. 1.2, the segment addition postulate. If B is between A and C, then AB plus BC equals AC. Now what this is talking about is we've got a line. We have A, B, and C, right? They're all in the same line, so I can say that the B is between A and C. And what I'm saying is AB, this length here, and BC, this length here, is the whole thing, right? Hopefully we should be able to see that, right? If you break something up, then you add it back together, you get the original. All right, number 3, I think this was the last one. Yeah, yay. All right, points X, Y, and Z are collinear, right? They're all in the same line, with Y between X and Z. So let's draw that. We've got X, Y, Z. Okay. XY is 20. XZ, that's this whole thing, is 25. Find YZ. Okay. So now I'm going to say, well, my two small pieces equals the big piece. So 20 plus X is the whole, 25. Right? I solve this, I'm going to subtract 20 from both sides, and I get X equals 5. Okay. To put that back in terms of what the problem says, I'm going to say that YZ equals 5. Okay. Now, I just want to go over an easy mistake that we could make. YZ segment is not 5. This is not something that we say, right? Whenever we're talking about the length, that little line above there is not there, okay? All right, that is all. I'm going to post this, and good luck on your homework.